Alright, let's work on this together. We'll work on the whole thing together. A girl travels 20 miles on her bicycle. The trip takes 2 hours. Express her speed in miles per hour. So the general technique in solving these problems is first we identify our variables. So 20 miles, distance, 2 hours, that's our time, and we are looking for her speed. So write down the variables. D is 20 miles. Time is 2 hours. We identify our equations. So speed is equal to distance divided by time. Plug in our numbers. And then calculate. Plug into the calculator. So our speed is 20 miles an hour. A car starts from a stoplight and is traveling with a velocity of 10 meters per second in 20 seconds. What is their acceleration? So if a car starts at a stoplight, that's talking about their initial speed or velocity, and it's traveling with a velocity of 10 meters per second east, so that would be our final velocity in 20 seconds. By time, and we're looking for acceleration. So final was 10, initial was 0, so this we assume is 0, because if you're stopped, you're not moving. And a time of 20 seconds. Our equation is acceleration is equal to Vf minus Vi divided by T. Plug in the numbers, and then plug it into a calculator. So going over the vocabulary terms, constant speed means your speed is not changing. Velocity is speed with a given direction, so it has a direction attached on it. Frame of reference, a background used to judge motion or speed. Instantaneous speed is a speed at a given moment in time. Speed is the amount of distance traveled in a certain amount of time. Average speed is the total distance divided by the total time. We aren't doing time distance graphs right now, but it's a graph that shows the speed of an object. Acceleration is how much your speed or velocity is changing over time. So it's a change in velocity over time. Motion is an object changing its position or distance in time. And rate of change is the amount of time it takes to change position or motion. So what is the speed of a rocket that travels 9,000 meters in 12.12 seconds? So what is the speed? So we're trying to solve for speed of a rocket that travels 9,000 meters. So that's our distance, 9,000 meters in 12.12 seconds. So that's our time is 12.12 seconds. So we can use our triangle. Speed is equal to distance over time. And we're solving for speed. So V is equal to D divided by time. Plug our numbers in. 9,000 for the D. 12.12 seconds for the time. Plugging that in the calculator. (742.57 meters per second). Put 4 or 5 numbers or digits whenever doing a problem. I tend to always put 5 or put at least 4. So let's do number 2. So what is the speed? So we're trying to identify speed of a jet plane that travels 528 meters. That's your distance. And time of 4 seconds. So we're solving our speed. So we do speed is equal to distance over time. Plugging in our numbers. And that'll be 132 meters per second. Alright, try working on number 3 by yourself. Can, but we're doing the whole thing together. You finished? Yeah. Everyone done with number 3? You can continue working if you want to. So pay attention. Alright. Number 3. Let's see if everyone did it. How long will your trip take in hours? So time we're solving for. If you travel 350 kilometers, that's your distance. With an average speed of 80 kilometers per hour. So we're solving for time. Time is equal to distance divided by velocity. So that would be 350 kilometers per 80 kilometers per hour. And that gives you 4.375 hours. Everyone get that for number 3? 4.375 hours. Alright, work on number 4. Finish number 4, Kaylee? Did you finish number 4? What about you, Hunter? Finish number 4? Tell me when you're finished, Kaylee. So what'd y'all get for number 4? What'd you get? 18's wrong. What'd you get? Wrong. What'd you get? Wrong. Everyone got it wrong. So let's do number 4 together. How far in meters? So we're trying to figure out a distance. You travel in 3 minutes. That's your time. Running at a rate of 6 meters per second. Your speed. Note, this is in 6 meters per second. Your time is in 3 minutes. Y'all see a problem there? So your time is 3 minutes. But how many seconds are in 3 minutes? No. Nope. What? Seconds? There's 60 seconds in 1 minute. 180 seconds. There's 180 seconds in time. And our speed is 6 meters per second. So, doing our triangle, well, speed is equal to distance over time, and we're solving for distance. So distance is going to be equal to velocity or speed times time. So our speed was 6 meters per second times the time. We have to use 180 seconds. The seconds will cancel each other out, giving us 1,080 meters. I just canceled out the seconds. So distance, 3 minutes is the same thing as 180 seconds, right? So we need to use, for time, we need to plug in seconds, because this is in seconds. Does that make sense? So your speed is 6 meters per second. So we need to use seconds for our time, because we're talking about how many meters you travel every second. So you travel 6 meters every second. So we're going to need to multiply by seconds. So 180 seconds. 180 seconds is the same thing as 3 minutes. Did y'all at least get the equation right? You have to pay attention to units. If you leave units off or don't pay attention to units, you get the whole answer wrong. So do number 5. So number 5. A trip to Florida takes 10 hours. That's our time variable. The distance is 816 kilometers. We're finding speed. The time is 10 hours. A distance of 816 kilometers. And we're looking for speed. Speed is equal to distance over time. Distance of 816 kilometers divided by 10 hours is equal to 81.6 kilometers per hour. So how many seconds will it take for a satellite to travel 450 kilometers at a rate of 120 meters per second? Let's look at units. This speed uses meters, but the distance uses kilometers. They don't match. How many meters are in 450 kilometers? How many meters are in 450 kilometers? What does kilo mean? 1,000. So we can replace kilo, so kilometers. 450 kilometers is the same thing as 450,000 meters. So it's asking how many seconds. So we're looking for a time. Will it take a satellite to travel a distance of 450 kilometers, which is the same thing as 450,000 meters, at a rate of 120 meters per second. That's your speed. So we're looking for time. Time is equal to distance divided by velocity. So plugging that in, 450,000 meters divided by 120 meters per second. Note the meters will now cancel each other out, leaving you with just seconds. So that would give you 3,750 seconds. So pay attention to units. What is the speed of a walking person in meters per second if the person travels 1,000 meters in 20 minutes? Note, it's wanting you to find it in meters per second, but it tells you it in minutes. So you'll need to do some conversion. Yes. So you want your speed in meters per second. That means your distance needs to be in meters, and your time needs to be in seconds. So what is the speed? We're trying to figure out what speed is of a walking person in meters per second. The person traveled 1,000 meters. That's a distance in 20 minutes. Time. Our distance is 1,000 meters. Our time is 20 minutes. But we want our answer in seconds, so our meters per second. We'll convert that into seconds. 20 minutes is the same thing as 1,200 seconds. So speed is equal to distance over time. So you take your distance, 1,000 meters, divide it by 1,200 seconds, and that's your speed. Why would you do the big number on top? No. Alright. Number 8. A ball rolls down a ramp for 15 seconds. Time. If the initial velocity of the ball was 0.8 meters per second, and the final velocity was 7 meters per second, what is the acceleration? So the initial velocity is 0.8, final velocity is 7 meters per second. So time is equal to 15 seconds. Initial velocity is equal to 0.8 meters per second. Final velocity is equal to 7 meters per second. And we're trying to solve for acceleration. So acceleration is equal to Vf minus Vi divided by time. So acceleration is equal to Vf minus Vi divided by time. Final velocity minus initial velocity all over time. Plug our numbers in. So our Vf was 7 meters per second minus our initial was 0.8 meters per second divided by 15 seconds. So this is equal to 7 minus 0.8 is 6.2 meters per second divided by 15 seconds. And that is equal to 0.4133 carried. And our units would be meters per second per second. Meters per second per second. I don't like writing it like this. You will see the answer. You should write it like this. Meters per second squared. So the units are going to be the units of velocity divided by the units of time. Meters per second. Just simple math. What do you mean we're at? So try number 9. So number 9, meteoroid changed velocity from 1 kilometer per second. So that's our VI, initial velocity, to 1.8 kilometers per second for final velocity in a time of 0.03 seconds. What is the acceleration of the meteoroid? We're looking for acceleration. VI is equal to 1 kilometer per second. Our final velocity is 1.8 kilometer per second. Our time is 0.03 seconds. And we're looking for acceleration. So VI or VF minus VI, change in velocity over time. So acceleration is change over time in velocity, change in velocity over time. So that's final is 1.8 kilometers per second minus 1 kilometer per second divided by 0.03 seconds. 1.8 minus 1 is 0.8 kilometers per second divided by 0.03 seconds. And doing that would be 26.6 carried kilometers per second. But I prefer the answer we can take this second and divide it by second. So a kilometer per second divided by second is just kilometers per second squared. Everyone get that? Alright, try number 10. Mm-hmm. Figuring it out, Kaylee? So what'd y'all get for number 10? For number 10? Or was a kilometer anywhere in that problem? What'd you get for number 10? What'd you get? You got what? Confused? Alright. A car going 50 miles per hour. So that's your initial velocity. Accelerates to pass a truck. 5 seconds later, time, the car is going 80 miles per hour. Yeah. Calculate the acceleration. So what is your car initially going at? It's initially going at 50 miles per hour. This fly's annoying. Your time is 5 seconds. And the final speed is 80 miles per hour. We're looking for acceleration. So acceleration is equal to final speed minus initial speed divided by time. So that would be 80 miles per hour minus 50 miles per hour divided by 5 seconds. 80 minus 50 is 30 miles per hour divided by 5 seconds. That gives us 6 miles per hour per second. Note, if you do not put miles per hour per second, then you get a point taken off. Units are very important. They're doing that super early. So they're doing that super early. Yeah. So work on the next 3 problems on your own. We'll do them tomorrow.